On to Chapter 4, Carbohydrates. Let's start with a basic review of our simple carbohydrates versus the complex. Remember, the simple carbohydrates are simple sugars. And here we can see the disaccharides, sucrose, maltose, and lactose, and the monosaccharides, one sugar, fructose, glucose, and galactose. Now I have this picture to represent that sucrose is table sugar. Anytime you see sugar on a label, this is referring to sucrose. Sucrose is made up of fructose and glucose. Maltose is made up of 2-glucose, and that's malt sugar. Lactose is a milk sugar, and that's made up of glucose and galactose. You do need to know what each of these disaccharides, the monosaccharides that are contributing to them. You also need to know, so you need to know the difference between the monosaccharides and the disaccharides, and that they're all simple carbohydrates, or we call them simple sugars. So on the exam you might see a question like this that says, which of the following are disaccharides? And it might have fructose, glucose, galactose, and maltose, and you would choose maltose. And what are our complex carbohydrates? Well, we have starch. Remember, this is just a bunch of glucose that are linked together. Starch is the plant storage form of carbohydrate, or essentially sugar. Glycogen is our storage form of carbohydrate. Remember, we just reviewed that glycogen stores are in the liver and in the muscle. This is how we store carbohydrate. And then there's fiber. Again, it's the same basic component, but we cannot break down these bonds in fiber. Therefore, for the most part, it goes through undigested. So going to the digestion and absorption, let's start with a bagel. And the bagel, it contains mostly what? Starch, right? Remember, starch is the plant storage form of carbohydrate, and it ends up into these glucose chains. So we start with, let me ask you, think about this. Where does starch digestion or carbohydrate digestion begin? Well, it begins in the mouth, right? We have enzymes in the saliva which start breaking it down. It goes through the esophagus into the stomach, pretty much halts there, moves through to the intestines, and this is where these components start to break down into smaller glucose chains and then into maltose. What is maltose? Maltose is 2-glucose linked together, and then that goes to glucose. Now from there, and this could be for any sucrose is going to divide into fructose and glucose. Any of the lactose from milk is going to go into glucose or galactose. In all aspects, we get down to these simple sugars, right? So we have glucose, we have fructose, and galactose. They all end up, this is supposed to be an intestines right here. Now, once they're in these very simple components, very simple sugars, then they're absorbed through the intestinal cells into the bloodstream. So they've got to be broken down to this stage, and then essentially go to the liver. Now, glucose can be picked up by other cells for energy, but for the most part, they head to the liver, and from there, and I apologize, this should be blue here, but everything ends up as glucose. It's going to be metabolized to glucose. So the galactose and fructose get converted into glucose, because glucose is the energy form that the cells can use. You do need to know blood glucose regulation, so I'm going to go through this again. Let's start with the bagel, because it's a very starchy food. We know that the bagel has the starch, it breaks down to the glucose chains, the maltose, and then glucose. So once you eat the bagel, this is going to send sugar into the bloodstream, glucose. This is going to give a high blood glucose. The pancreas responds with insulin. Insulin is released, so now there's both insulin and glucose in the bloodstream. Insulin assists in the transport of glucose to the muscle, the fat, and the liver. I don't have that shown here. And once the glucose comes out of the bloodstream, this is going to decrease back to a normal blood glucose. So the goal of the pancreas releasing hormones is to normalize blood glucose. So what if you skip a meal? We have a low blood glucose, right? You don't have any of that glucose, food breaking down to glucose in the bloodstream. In response to that, the pancreas releases glucagon. Glucagon stimulates the liver to release glycogen. Remember, glycogen is stored in the liver and the muscle, but only the liver is willing to share its glycogen. So glycogen is released. Now, what's glycogen? Glycogen is our storage form of carbohydrates. So glycogen is broken down to glucose, and glucose is released into the bloodstream, so it normalizes blood glucose. Now, this is just referring to if you don't have a really highly refined carbohydrate, you're eating a whole food, it's low sugar, it's low starch, it has high fiber, then you have more of a steady stream of glucose. And the blood glucose is more likely to stay relatively at a relatively normal level as opposed to having these spikes high and low. Because if you eat this bagel, you get a lot of glucose, you get a lot of insulin. And then this drives it into the cells, and then it really lowers the blood sugar drops. So remember, you get the sugar high, sugar low, sugar high, sugar low. So there'll be a question on the exam saying that if you had, a toast and jam or something for breakfast, why do you feel starving an hour later? And it's because of that process that you're eating this really refined carbohydrate that gets absorbed into the bloodstream quickly. High insulin is released, a lot of insulin is released that drives all the blood glucose out of the bloodstream, and then it drops the blood glucose. So then you end up on the sugar high and sugar low. So this is the type of question you're going to see on the exam, and if you know this process, it will be very easy. If you don't know this process, you're going to be struggling a little bit. But you'll see a sequence of events, and they're going to be out of order. So you'll see these events, but they're not going to be in order, and your job will be to put them in order. You'll have to say, well, 2, 4, 1, 5, and 6. So you may want to have a piece of scratch paper handy so you can write this down. But always I can look for starch. That's going to be your beginning process. We'll start as starch, or look for the organ it starts in, say the mouth. So we know that starch is going to break down to glucose chains and maltose in the mouth. That's where it starts. So now we have maltose, which breaks down to glucose in the small intestines. Remember, carbohydrate digestion halts in the stomach. Glucose is then absorbed from the small intestines into the bloodstream. The pancreas responds to this increase in blood glucose by releasing insulin. Insulin then transports glucose from the bloodstream into the cells, where the cells use it for energy. That results in a blood glucose decreasing or normalizing. So what are the guidelines? How much carbohydrate do you need? Well, it's somewhere between 45 to 65% of your diet. Fiber is about 25 grams a day for a woman, 38 for a man. You definitely need to know that added sugar is less than 5% of your diet. This will be on the exam, and you also need to know it for your diet study. You will not find this value in your textbook. This is the American Heart Association value. It's about 6 to 9 teaspoons a day, or 25 grams. Also, reduction of refined carbohydrates. So these are the 2010 dietary guidelines, with the exception of added sugar. That's the American Heart Association. And what I want you to know. Well, this slide came out a little bit wrong. My E's off on the insoluble, but looking at soluble versus insoluble fiber, they both have important functions. When you think of soluble fiber, I want you to think of something more viscous or gel-like. And when you add water to oatmeal and you cook it, it becomes a little bit more jelly-like. You're not gonna have those individual oats. Also, pectin is an example of a soluble fiber you find as an additive in foods, especially jams or jellies, because it really helps with the solubility and creating that gel-like substance. Insoluble, this means it's non-viscous, it's not going to dissolve. Think about brown rice and how if you cook it and it's light and fluffy, you're going to have a lot of insoluble fiber, and it's going to be separate. You're going to have those separate little pieces of rice. Another example of insoluble fiber or a food with majority insoluble fiber is celery. Think of that structure of the celery. When you eat celery and you have all these like strings that are caught in your teeth, that's the insoluble fiber. That's not going to dissolve in water. Soluble fiber, what I mainly want you to know about these two is the functions and the health effects. Soluble fiber slows the absorption of glucose. It helps to lower cholesterol, slows the transit of food in the upper GI tract, the intestines, holds moisture in stools. So when you slow the absorption of glucose, you decrease the risk of diabetes. When you lower cholesterol, it decreases the risk of cardiovascular disease. Insoluble fiber increases fecal weight. This is working mostly in the colon. It's speeding the transit in the colon. It's contributing to satiety. It decreases the risk of colon cancer, of appendicitis, of diverticulitis. Now, what about sugar? When we're talking about added versus natural sugars, remember that a naturally occurring sugar is going to be what occurs in a whole food in nature. Fructose, as in fruit and vegetables, lactose in milk, and then you'll get some glucose and sucrose in fruit. Honey does occur in nature, but it occurs in, it's still 99% sugar. So it's important to know that when you take that and add it to food, it's an added sugar. We consider it an added sugar. So sugar, added sugars, these are sugars that are added to foods. Anything that is added to a food. If you see it on an ingredient label, it is an added sugar. Sugar, high fructose corn syrup, fructose, and honey. Honey is an added sugar, and you'll see that on the exam. And, I always have to give my little side note to honey. Most honey in the United States is highly refined and is no better than table sugar, than the sugar here. Raw organic honey from the farmer's market that you generally have to scoop it out. There's no plastic squeeze bottle that it's going to come in. Does have some redeeming benefits, and that is probably better for you to add to your food than regular sugar, but it's still an added sugar. You would have to eat so much of it to gain a lot of health benefits, but you don't want to consider it a health food. You still need to have less than 5% of your diet as honey. You definitely need to know the difference between type 1 and type 2 diabetes, and here are the key aspects I want you to know. And there were some wonderful cartoons in the discussion forum that helped define the differences, and those are always great to see. So the onset. Type 1 is typically in childhood. It does not occur in adulthood. It can occur in late adolescence, rarely in the 20s. It's typically in childhood, generally when kids are 4, 5, 6, or 7. Type 2 diabetes, typically adulthood. We are seeing it in children now, but this is an acquired type of diabetes. The cause. Type 1 is an autoimmune disease. The body actually attacks the beta cells of the pancreas, destroys them. No insulin can be secreted. That's type 1 diabetes. Type 2, lots of factors contributing to it. Could be genetics, insulin resistance. It's characterized by insulin resistance. That means the cells can't recognize insulin. Usually there's too much insulin. I already mentioned genetics, obesity, abdominal obesity, and of course diet. And then physical inactivity. So lots of factors contributing to type 2 diabetes. And it's not something you catch. This is something that is multifactorial and develops over time. Type 1, the pancreas cannot secrete insulin. Type 2, the cells don't recognize insulin and usually overproduce insulin. So there's usually too much. Long-term diabetes, 10 years, 20, 30 years usually, the beta cells of the pancreas can burn out and then they won't secrete insulin more. So that's a very advanced stage of type 2 diabetes. The incidence, most diabetes is type 2, 90 to 95% of the cases. Only about 5 to 10% of the cases are type 1. So what are the risk factors? Well, abdominal obesity is a main risk factor. Diet, so we look at a lot of processed foods, refined carbohydrates. These are really going to contribute to the development, a decrease in fruits and vegetables, physical inactivity, and then genetics. But just because people in your family have type 2 diabetes does not mean you will get diabetes. That's really important to understand. Type 2 diabetes is characterized by insulin resistance, meaning the cells don't recognize insulin. Therefore, you can't bring the glucose into the cells. So what are refined carbohydrates? Table sugar, any sugar that's added to a product. Cereals have a lot of added sugar and are a very refined carbohydrate. Lots of basically starch in cereals, as well as bread. Bread also usually has added sugar. Pasta, very refined carbohydrate. White rice. So all of the whites, when you think of, if you want to eliminate anything, eliminate the white stuff. You are going to have to identify the aspects of the kernel, the grain kernel. What's not shown here is the husk. The husk is considered toxic. It's always removed. That's this portion right here. So we can get to the kernel. The outside is the bran. This contains the fiber. The endosperm contains mostly the starch, and the germ, this is the germ here, that contains protein and micronutrients. And those are the main aspects I want you to know for Chapter 4.